Marcus and I are about to give you an overview of some of our efforts standardizing Unicode-related regular expression features, both at the Unicode level, but also in ECMAScript, which is the standard defining the JavaScript language. So we're going to discuss the history of Unicode regular expression features, some feature work that has already happened and that can be used by JavaScript developers today, as well as some of our ongoing proposals that will hopefully become available soon. But let's start with the motivation behind all this on the next slide. And what better way to do that than with a little quiz, am I right? What does this regular expression pattern match? Now, some of you might actually recognize this as matching control characters, but I would argue that this is not immediately obvious, especially for folks who may not be as intimately familiar with Unicode as we are. So next slide. Luckily, there is a better or another way of expressing this, \p brace control close brace. And the control here refers to the name of a character property defined by the Unicode standard. I would say that this second pattern is not only more concise, but it's also more self-documenting. It's making the regular expression more readable and more maintainable. And these benefits scale up rather quickly. On the next slide, we see a more complicated example. And I could ask the same question, like, what do you think this pattern matches? And it's probably not very obvious, right? There's a lot of escape sequences here referring to specific Unicode code points. Maybe it helps to look at all the raw characters on the next slide, but I'm not sure if it actually helps all that much. But on the next slide, now it's actually a lot clearer to see what's going on. This pattern matches all Greek characters according to the Unicode standard. And this ability to directly refer to Unicode properties within regular expression patterns is really powerful, not just for readability and maintainability, but also for future compatibility. So these three last patterns that we looked at, they are all equivalent according to Unicode 14, but only this version that you're looking at right now has an auto-update feature. If, say, a new Greek character gets introduced and makes its way into the Unicode standard, then this regular expression automatically starts matching that character as soon as the host environment, in this case, the JavaScript engine, updates its internal Unicode database. The handwritten patterns that we looked at earlier, they would need to be manually updated and then rolled out and deployed. So these Unicode property escapes allow you to express intent rather than implementation, which is really powerful. Now, let's take a look at what Unicode was doing about regular expressions.
Yeah, so just briefly, there has been work on this before. There has been work in a Unicode spec, the Unicode regular expression standard, and also in sort of iterating with Unicode and with other regular expressions. ICU has a class called Unicode set, which implements basically the functionality that you know from regular expression character classes. And we're going to get a little bit into what that does, but first Mark is going to talk about sort of how the Unicode spec came to be and how it evolved.
Yeah, so I'll give a little bit of history. We started out in the last century, and Unicode had been developed. We had developed properties as well as the character encoding, but we were not seeing the pickup by regular expression engines. And partly because Unicode was very new, very different. It really was a dramatic extension of what people were used to using in regular expressions. So at that point, what we needed to provide some structure and some guidance to all of these regex engine developers so that they would have some idea of what to do with this really new thing. And we put together the first version. You want to click through? Try that. Okay. This was the very first public version, which was in just the very end of the millennium, so 1999. And you can tell by the very, very retro formatting, which is not, I mean, the current Unicode site is very retro anyway, but this was even more retro. And so is to set out how you should deal with these things. And what we decided to do it in terms of levels and particular features, so that a regular expression engine could say, well, I implement level 1 feature X, or I implement all of level 1 and I implement this feature from level 2. So we made the conformance very broad, and the whole goal was to give people a target. And this worked actually very well. We can go back to the other one, just maybe back button. Yeah, so we ended up in 2002 adding properties, additional properties, subtraction and intersection. These turn out to be very interesting because often what you want to do is you want to say, well, I want all the Greek characters except for pi. And if you don't have the ability to do subtraction, then you can't express that. What you have to do is list all of the characters individually, which means they don't auto-update. So we added subtraction and intersection to that. If you go back. Then we added, and you don't have to click through at this point, we added names, wildcard properties, we added graphing clusters, because it turns out that graphing clusters, where I have a constant plus some diacritics on top of it, for example, or I have grapheme clusters in Indic languages and so forth, those are often the kind of object that you want to deal with. You don't want to deal with just individual code points. Then we expanded the properties in 2012, and just recently we added string properties. And we'll get more into those, but one of the impetuses for string properties has been emoji. Now, there are other reasons to have string properties, but for example, the characters of a language are typically given not just as single code points, but often as combinations. There are languages that have a CH as a character of their language, but they're missing either a C or an H. So it would be invalid to have an isolated C, but it's not invalid to have a C in combination with an H. So let's go to the next slide. So we had a lot of experience in ICU in dealing with these kinds of things from pretty early on, and we had Alan Liu, who did a lot of that work back when, because we had to deal with these kinds of things for transforms. And we wanted to have a kind of subset of the regular expression capabilities for transforms, but we absolutely needed to have all of these features of properties and intersection and union and so forth as capabilities for this purpose. And we developed Unicode set. And Unicode set is a compact representation of a set of code points that can be built out of properties and so on and so forth. And it's compact and it's reasonably fast. And so that's what we use. The structure that we use internally is what we use in a number of other places as well. And next slide. So in the early 2000s, we had sets of Unicode code points. We have multiple character strings. We have more properties. So this is all quite a bit before we had these capabilities and needed these capabilities for things like emoji. Here's an example from Czech where you have a C and an H as treated as a single character. In this case, in Czech, you also have the isolated C and H, but there are other languages where you have combinations that aren't individually represented. Next slide, please. In 2022, we also made a few fixes to the way that Unicode set worked. Is that we added the empty string, which was not, you were not able to represent the empty string, but it turns out for generality you want to be able to do that. The second thing we added was we added emoji properties of strings, and these were the first Unicode properties, not CLDR properties, that really had sequences of characters. And one of the key things about it is, if you look at this example right here, the writer of a regular expression doesn't know and doesn't need to know that a flag is really made up of two characters. And it's really two code points underneath the covers that are merging together to form this flag emoji. And it turns out a majority of all emoji are composed of multiple code points, because you have things like skin tones and gender and so forth. So we have a host of different emoji, and a majority, as a matter of fact, are composed of these multiple code points. And you really need to have a mechanism so that if the user doesn't know, they can just put curly braces around an emoji and they're safe. They're not actually including what they didn't mean to include. And I think that's okay. And one of the innovations that we have just recently added to the working version of UTS 18 comes out of the work on ECMAScript. And that is the ability to have a more compact form for these strings, where you can start off the say that I've got a whole set of different strings that are part of this Unicode set, separated by a pipe symbol, so that it's much more compact than if you have to list each of one of themselves by itself with an introducer. And I think that's the last one. Let's see. Why don't you go ahead? Bingo.
Yeah. All right. Yeah, so as part of trying to add more regular expression Unicode features to JavaScript, sometimes you end up discovering or coming up with these problems that are not yet well defined at the Unicode level. And that's why this work spans across multiple standards bodies in a way. To solve the problem, we try to make sure the terms like properties of strings, for example, it started as a proposal at the ECMAScript level, but it made more sense to define the concept of a property of strings at the Unicode level first, so that not just ECMAScript, but also other languages can potentially benefit from this. So now I want to talk a little bit more about adding \p and just the core concept of property escapes to JavaScript. UTS 18 provides a great foundation to build on, but before a programming language can adopt its features, generally additional standardization work is necessary to integrate with that language. So back in 2014, we set out to bring property escapes to the ECMAScript standard, which defines the JavaScript language. And the very first pieces of this work were rather subtle, so I'm going to provide some history and talk about some work by other people as well. And you should know that ECMAScript is versioned by year these days. There is one major new specification snapshot per year, and the first version to adopt this naming scheme was ES 2015. So on the next slide, exactly. ES 2015 was set to include several new Unicode-related features, with people like Norbert Lindenberg and Alan Worms-Brock driving the specification work for those. So prior to the ES 2015 release, we were involved with reviewing the spec text for some of these features. And one of the more interesting features to me was the new U flag for regular expressions, which opts into a more Unicode-aware mode. This was long overdue because without this flag, JavaScript regular expressions only properly support BMP characters, so code points up to FFFF. The U flag is pretty amazing. It enables code point syntax, the first example you see here, and it generally adds support for non-BMP characters in regular expressions, fixing the behavior of things like dots or quantifiers or character classes. Unfortunately, property escapes were not part of the new features enabled by the U flag. So what we did is we lobbied to ensure that the \p syntax got reserved to keep this option open for the future. And you see this on the next slide. On the one hand, it's kind of sad that maybe property escapes weren't included from the beginning, but on the other hand, it's great that \p was made to throw an exception, because it meant that we could go back and fix it later without that being a breaking change. So overall, this was just a very small tweak in preparation. but we were really planning ahead. And another such minor tweak involves the HTML standard, which is perhaps a bit of a surprise. On the next slide, yeah, exactly. You see here the HTML input and text area elements support a pattern attribute, which allows developers to specify a regular expression pattern for input validation. The browser then provides you with styling and scripting hooks to make stuff happen based on the input's validity without you having to write any JavaScript. In this example, we're giving valid inputs a green background and invalid inputs a red background. And so what we did many years ago is we successfully proposed implicitly enabling the U flag for any regular expressions that are implicitly compiled using the pattern attribute. We did this to make HTML forms more Unicode friendly, but also because we knew that it would, in the future, unlock the use of property escapes in HTML. Now, on the next slide, you see the project we started after the release of ES 2015. We started work on a proposal that adds support for property escapes to JavaScript. And this involves championing the feature based on its use cases, driving consensus at TC39, which is the committee that governs the ECMAScript standard, and proposing the concrete changes to the specification text, including the new regular expression grammar and its semantics. Along the way, we actually made some decisions that differ slightly from UTS 18. And you can see those on the next slide. First of all, we decided to not apply loose matching. UTS 18 recommends to ignore case, white space, underscore characters, hyphens, and the is prefix when resolving property and value names. But we, on the TC39 side, we felt it's simpler not to do this initially. And in a way, it's kind of nice to be more strict in this case, since it reduces the number of different ways that the same expression can be written. Second, we decided not to support the full list of UTS 18 properties. You can see this on the next slide. One of the unsupported properties is block, which UTS 18 explains is very easy to misuse. And it's kind of limited use because it only assigns a name to segments of the Unicode code point space. So if you were to do something like block equals Greek, for example, that's a little bit misleading because it would only get you a subset of characters in the Greek writing system, which is probably not what you intended to do. You would be missing out on Greek extended and on combining the critical marks in that case. So for that reason, we decided not to support block. And so far, we haven't heard any complaints. We also don't support the name property yet, but we might add support for it in the future. On the next slide, you see that after a few years, Unicode property escapes eventually landed in the ECMAScript standard and officially shipped with ES 2018. So nowadays, all modern JavaScript engines support them, and this functionality is available in environments like Node and web browsers alike. But that didn't happen until June 2020, just last year, when Firefox became the final major browser to add support for \p. So long story short, standardization and implementation can take some time. And on the next slide, thanks to the HTML integration that we took care of many years before, you can now even use property escapes for form validation in HTML. In this example, the value of the input field is hello world in Greek, unless I made a terrible mistake, that is. And yeah, next slide. And that is where the story ends. No, I'm just kidding. We were only getting started. On the next slide, you see some of the things that Mark already hinted at. Property escapes by themselves already solve plenty of problems, but there are still scenarios in which they're not as helpful as they could be. For example, how would you match all Greek characters except for the letter pi? There's not really a straightforward way to do it currently, other than going back to handwriting all the characters and then removing one of them. But that's very painful to do. For this kind of use case, it would be wonderful to have support for set operations. On the next slide, you see what that could look like. So imagine creating a character class that starts off with a Unicode property and then subtracts the character or characters that you don't want to match. That way, the regular expression engine would do the hard work for you while keeping your code readable and maintainable. Another missing piece is shown on the next slide, which is the lack of support for properties of strings. So As we mentioned, we already support character properties, such as the emoji property, but these character properties only ever match one character or one code point at a time. And some graphemes, like the flag of Scotland emoji, for example, are represented by multiple code points, and these cannot be matched with character properties as easily. On the next slide, you see that it would be really useful to support not just properties, I'm sorry, that expand to a set of characters, but also properties that expand to a set of strings. So that way it would become possible to do things like matching flag emoji regardless of how many code points they consist of. And combined with set notation, you could even imagine matching all emoji that are recommended for general interchange except for the flag of Scotland, for example. So these are some of the proposals that we're currently working on. And as it turns out, some of these ideas are not entirely new. And I think Marcus is going to talk about that now.
Yeah, so what we have is we have a regular expression standard in ECMAScript, and we've got existing prior art in terms of a Unicode specification. We have the Unicode set. How hard can it be, right? We just take the established syntax for set operations, we take the established properties of strings, stick them in, make a nice little proposal, and that's going to be just easy and fine. Well, we actually had a bit of a back and forth. We have been working for over a year on getting serious about this and figuring out in meetings among ourselves. We have also a colleague, Shane, I don't know if he's in the room today, who has been discussing with us where this should be going. We also have some other people joining in and out. And we have iterated with the ECMAScript committee. Sometimes we have proposed things that didn't quite fly with the larger community. But we have now a proposal that we hope to move forward that is going to add new syntax. It's also going to make some changes that are not entirely compatible. And because of that, and because of a small number of semantic changes, this is going to add a new flag, which is proposed as the flag V on regular expression. So instead of using the U on the previous version, we would be using the flag V for having this version. And there's also a getter for that, and we had some bike shedding on what to call that. So where are we? We have actually a set operation, of course, in regular expression character classes, even in ECMAScript, that's the union. You can build up a character class from lots of little pieces, which are individual characters and ranges. You can also, thanks to Matthias and other people's work, add character properties. So in a way, there is already a bit of a nested set inside of a character class. But as Mark and Matthias explained, when you have large ranges of properties, especially order updating properties, you don't want to have to hard code them again when you have exceptions. You want to express the exceptions in a concise form, otherwise you end up expanding the whole thing again and lose the benefit of properties. For example, maybe we can even have this as a quiz or a test. Roughly how many sets of digits are there in Unicode? Any idea? 50? 50 is a good guess. Thank you. Unicode 13 had 65. Unicode 14 added one, so it's 66 now. If you want to just hard code the set of digits, you have 66 ranges in your regular expression. And of course, it's much better to write \p decimal number. And you have all of those 660 characters. But what if you don't want all of them? You want to find the non-ASCII ones. So you take all those 66 sets of digits, and you remove the ones that are in the ASCII range. Well, you should be able to just do that. Otherwise, you have to spell out the 65 ranges that are remaining. Here's another example where we have the Khmer script. And ECMAScript includes all kinds of characters, including also punctuation, but maybe we only want the letters, the marks, and the numbers. No offense to this mark, but these are things like combining marks and such. I'm sure Mark had a hand in naming the marks. But this is a place where the intersection is really useful. In some ways, you can actually simulate one with the other. You can make a subtraction, for example, by intersecting with the complement. But that becomes less obvious, less readable. There's also a limitation that we might get into when you have strings. But so these are the set operations that we were trying to add, that we are proposing to add into the syntax. Now, about the established syntax, we have a syntax in UTS-18, we have a syntax in Unicode set. They are not actually the same. And we did a survey of something like 10 other regular expression engines that have been standardized and used and are popular. They're all different in some ways. So we settled on a syntax, and we settled on using double punctuation, so the double minus and the double ampersand, which actually matches what UTS-18 has. And we are also allowing these nested character classes with the square brackets so that you can group things together like in a mathematical expression. So part of the reason actually to select the double punctuation is, number one, it looks more obvious that something special is going on. But also number two, at least in some of these cases, you can still use the single character on its own as a literal. Only when it's a double character, then it has a special meaning. We are also taking a lesson from what Matthias talked about in reserving future syntax. I'm sure that other people will come up with other features that make sense and are useful in regular expressions. So we are setting aside additional double punctuation mostly, but also the parentheses and curly braces for future use. We don't have a plan, we don't have a proposal for what to do with these, but it makes sense to have things reserved so that we don't need a new flag every time we add a new feature into the standard. And there is, of course, an operation that we are not currently proposing. That's a symmetric difference that you can see in math context, for example. We don't see a large use case for that, but someone could use one of these syntaxes and use that. We also are kind of overloading more than before the dash or the hyphen minus character. And as you've seen, we are using it or proposing to use it for subtraction, to remove things as exceptions from a larger set. But of course, also the single dash is used for a range, and a single dash can also occur in the character class. And the way we deal with that is, well, the double dash will be the subtraction operator. The range is like before, but when the two of them get together, we require you to add brackets so that it doesn't look totally confusing. In other words, the range syntax with a single dash is only allowed in the union syntax. So you can have more things in the brackets, but you cannot mix the range syntax indirectly with subtraction and intersection. And then there are some special tricks that depend a little bit on the regular expression syntax. Sometimes you can use the dash as a literal in some places, but not others. And in discussion with the larger ECMAScript committee, it turned out that people actually prefer having a simpler, more predictable syntax. So if you actually want a dash, you have to escape it one way or another. For example, just putting the backslash in front of it. So we went through this kind of stuff and a number of other things on our journey to develop a proposal. One of the topics that we discussed for a long time was the operator precedence. Whenever you have some expression syntax with multiple operators, like think of math, plus and minus and division and division and multiplication, there is a rule for which of them binds more strongly. There is not, as it turns out, any kind of accepted standard for doing this in regular expression character classes. There appears to also not be any real standard for doing this in general math or in Boolean operations. And we had, among different people, different intuitions for what made sense. So we ended up basically agreeing to play it safe, but be still not too clumsy. So we could require brackets everywhere, but we didn't want to do that. We do require brackets when you mix operators. So in the second half of the slide here, we have the intersection here of Greek, for example, with something else, and the whole something else is in brackets, and that is a union of properties. So what we get here is Greek on one side, meaning the Greek script, the characters in the Greek script, intersected with all of the letters, the marks, and the numbers. The second example here has a subtraction on the left. We are taking any and all code points in Unicode. We are removing this thing that's called other, that's really including the unassigned code points, the control codes, the surrogates, the private use, and things like that. But then we are adding the control codes back in, and so we have a union that re-expands what the contents of the set is. And there is another example here that has a union on the left and then subtracts, in this case, unassigned code points. We don't require brackets when you have multiple of the same operator. You already have that, of course, implicitly with the union. You just glue things together one after another, but the union is totally easy because it's also symmetric. For things like the subtraction and intersection, we have to define what gets evaluated first, and we decided that it's most natural to have it left to right. So we take this other category, then we remove the format, and then from the result we remove the control codes. So here are the emoji properties of strings. And just to be clear, there are kinds of two ways of validating emoji. And if you look at the emoji spec in Unicode, UTS-51, generally there is a syntax for what could be a valid emoji, and that is expressed itself in regular expressions. And it can match an infinite set of strings, and they can, in some cases, be infinitely long. But Unicode also provides data files with finite sets of strings for the things that basically vendors are expected or have agreed to support in input palettes and in fonts and in other kinds of systems. And so this is what we are after in encoding, because otherwise you have to hard code kilobytes of hard-coded regular expressions to list all of these things. And this is what we are trying to make available. There are several of these properties, and actually, I should also add terminology. Sometimes we casually call these string properties or sequence properties. There are properties where the value is a string. Think of a lowercase mapping. A lowercase mapping of certain characters can result in a sequence of characters. These are properties where the input, so to speak, is a string. In this case, the value is just Boolean yes or no. Is this an emoji or is this not an emoji? But the values are simple. The inputs are the strings. Most of the time for these guys, the basic emoji actually includes single character, single quote point emoji, as well as some sequences. And I leave it to homework for you to figure out which one is which in this case. There's a mix on the slide. And I apologize for some part of the rendering stack that smashes together the keycap sequences. But all of these middle properties here only contain strings. They don't contain single quote points. The RGI emoji, RGI stands for the recommended for general interchange set. This last one here is everything that is above. And there are some 3,500 code points and strings in these sets. It's actually interesting in terms of standardization, history, and forensics if you see the flag sequences include the flag of Gibraltar, but if you want the flag of England or Scotland, you have to have a tag sequence. I'm sure Mark is happy to explain that later if needed. And these things work together. You can have a character class or a set in a regular expression that has properties of strings and also does subtraction and intersection. The first example here takes all of the basic emoji and intersects it with the symbol set. So on the left side, we have something that contains both code points and strings. On the right side, we have something that only contains code points. As a result, of course, the entire character class only contains single code points. The second one is using two properties of strings. The first one is all of the recommended emoji. The other one is the flag sequences, which means it's all of the emoji except for the flags. Actually, only the sort of main flags. This actually still contains Scotland, but it no longer contains the flag of France, for example. There are things that are not desirable or really weird, and we are forbidding them. And that's also a result of discussion among ourselves and with the committees. When you do a complement, which is indicated by the circumflex, that says that the contents of the character class is not what it says on the right side, but it's everything else. When you extend that to strings, it gets really hairy because in principle there's an infinite set of strings. And we are forbidding that. So in this case, the stuff to the right includes strings because we have a union of the keycap sequences and the symbols. And when you do a complement of that, because we have strings, that gets into things that we don't even want to think about, and instead you get an actual syntax error very early in writing this. You're not going to be able to have valid JavaScript or ECMAScript code that does that. On the other hand, if you do an intersection, all the strings from the left side disappear. You only get those keycap sequences that are also symbols, which is actually the empty set, but it works for any of these properties. You do the complement, and because it's a complement of only code points, it works just fine. And then, I'm sorry, my voice is leaving me. Then we have an example of expressing hashtags that include and allow emoji as a practical. We have, I think I'll survive that. Sorry about that. So one of the last pieces here is the string literals on a syntax level. When we have properties of strings, we also want to be able to have exceptions and additions, just like we have with properties of characters. For that, we need a syntax to have a string just as itself, not as part of a property. And ooh, I have an interesting pop-up here. Guess you don't see that. So we have a syntax. We went back and forth on this as well between ourselves and the committee. We ended up with the same thing that UTS 18 provides, whether it's the \Q curly brace, and in the process we came up with the pipe symbol for an abbreviation so that it's a bit less tedious to type a sequence of strings into a character class. There is one final item here in terms of semantics. Sorry, I have to dismiss something here. And that's case-insensitive matching. When you have the I flag on the regular expression, that means that it will ignore case distinctions. And we needed to define something about how that works together with our syntax that allows nested classes and allows these operations. And we stumbled on something really weird that feels like a real bug. And that is, if you look at these expressions on the left side and the right side, it looks like they should just match lowercase letters. And when they match ignoring case, you would expect that they match all letters, or at least all the case letters where there is a lowercase and uppercase pair. But the one on the right doesn't. It doesn't actually match any letters. Even though, if you look at it, the backslash uppercase P should say it's the complement of what's in the braces, and the circumflex should do another complement. It's a double negative. A double negative is nothing, at least in standard English. But in fact, these do very different things, and we are proposing to change the internals of how this is processed. And the right side is going to work like the left side in this case, and you'll get all case letters. So on the way of going through this proposal, we actually, I think, are fixing a bug that is very confusing. So I'm getting time signals here. We have this one slide left. This is just the status of where we are. We have an ECMAScript proposal where we have happily resolved all of the open issues. We are going to have to produce spec text next that is a real delta on the specification and take that to the next level at ECMAScript. We have UTS-18 with a pending public review for updates where we have done, mostly Mark has done a lot of good work on clarifying the spec and adding the abbreviated string literal syntax. And in ICU, we have recently added the things we talked about, but also there is some work that will make it easier for regular expression engines using ICU to implement the ignore case processing. And with that, we can open up to questions. And I think we will either have to repeat questions or hand around the microphone. Maybe start by...
Faster to just repeat the question.
Yeah, we'll repeat them.
Sounds good. Oh, stunned silence. Bob!
Maybe I was slightly off topic. I mean, I've been following Redis for a while, but I know one of the pushbacks always has been about performance issues. ICU versus PRE or versus whatever. So what are we doing to address kind of the performance concerns to get more ICU adoption?
So Bob's question is about performance, and sometimes people complain that when they expand something and start using ICU that it doesn't perform well. When we talk about character classes and regular expressions, we are talking about processing these at compile time, at pattern compile time. And what you end up with is a set of characters, and in this case, it's also a set of characters and strings. And in the proposal, we are taking the strings out of the actual set and turning them into an alternation. So think of writing an open parenthesis with all of the strings with pipe, and then at the end you have square brackets with the single characters. So in terms of processing, it works just like processing of regular expressions. You just don't have to hard code as much as before in the pattern that you're authoring. So the performance will be the same. If you do have strings, the regular expression engine will have to deal with those strings. But if you need to match those strings, you would have to hardcode them as an alternation anyway. So you're not gaining or losing any performance. It's just that the pattern compiler is smarter than before.
For JavaScript on the web specifically, there is actually a benefit because if you no longer need to send these hard-coded or generated kilobytes long regular expressions over the wire, you save on bandwidth costs. This can improve the page load time as well. It also saves initial parse and compile time from the JavaScript engine, so your JavaScript can actually start running much earlier just because you're sending fewer bytes over the wire that need to be parsed and compiled. So there is some benefit to it.
Actually, Marcus mentioned something earlier, but a lot of people don't realize it. If you say, well, how many emoji are recommended for use by Unicode, then it's about 3,500. If you say, how many emoji are valid in Unicode, then that's a trick party question for nerds, and that is infinite. There are essentially an infinite number of valid emoji characters because they can be in sequence. But that's not in regex. No more questions?
I have a question for Mark if there's no other questions. What's the deal with the flag versus tag thing that Marcus was hinting at?
What's the deal with what?
Flag versus tag.
Oh, like
yes.
The Scottish flag is, yeah.
These categories don't necessarily represent semantic differences. They represent the internal methods of encoding. And the three flags of England, Scotland, and Wales are special cases. Those are ISO 3166 Part 2 flags instead of Part 1 flags. And all of those are actually all valid. So there are actually around 5,000 valid Unicode flags, but only those three out of Part 2 are broadly supported. So we don't, so Unicode doesn't necessarily recommend that you support the flag of Catalonia or Brittany or et cetera, et cetera.
So if there are no more questions, we're at question.
Just quickly, what's the lead time to adoption? We're talking about JavaScript, but let's say if you want, when this comes out, how long do you think it take before this will get to other languages?
Matthias, you want to take that one?
Oh, you have to repeat
Yeah,
the question.
yeah. I think I heard the question. What's the lead time? Like, how long will it take for people to actually be able to use this in their programs, right? Yeah. So there is the standards process for ECMAScript works with stages. There's 4 stages where stage 4 means the proposal is merged into the official specification. But what developers are waiting for is not necessarily stage 4, but rather stage 3, because that means the proposal is considered to be mostly final. And at that point, implementers can start implementing the functionality. So at that point, you will start to see it ship in browsers. And one of the requirements to get to stage 4 eventually is that you need at least 2 major implementations. So like 2 different browser implementations, for example. Currently, our proposal is at stage 2. Once we, I mean, I can't predict the future, but once we write the complete spec text, we already have a pretty good draft right now, but we need to provide a proper patch and get that reviewed by the official reviewers. At that point, if everything goes well, the community will say, okay, we agree with the advancement to stage 3. And at that point, hopefully, we can start writing official tests. There's a centralized test suite for ECMAScript so that all implementations will run the same tests, which is really helpful for interoperability. So once we have the spec written, the tests written, at that point, it's a matter of people implementing these changes. So yeah, hopefully soon.
I think that's it.
So let's all thank Mark, Marcus, and Matthias for
Thank you.